Hey everyone, I'm Jacob. I'm a machine learning engineer and developer evangelist at Voxel 51. 51, for those of you who don't know, is the leading open source toolkit for curation and visualization of computer vision data, and 51 plugins are an extensible framework that allow you to customize the functionality of 51 for your particular workflows. We're currently finishing up a 10 weeks of plugin series where every week we bring you one or multiple plugins showing just some of the cool new things you can do with 51's plugin ecosystem. And today I'm going to be telling you about three plugins. So we're mainly going to focus on one of the three, but this is just an instance or an example of how you can combine and mix and match plugins to generate and to construct interesting workflows to suit your particular needs. So the three plugins that we're going to be working with are the PDF Loader plugin, the PyTesseract OCR plugin. So this does optical character recognition using the Tesseract OCR engine, and the Semantic document search plugin. Now, if you have the 51 plugins plugin or the management and creation plugin already installed, so if you go to the 51 plugins repo here, which has tons of awesome and helpful info about 51 plugins, how to build them, how to use them, and everything you can really want, you'll see in this core plugins section, there's this Voxel 51 plugins, and this is a plugin for management and development of plugins. This is our week 10 plugin. You can download this by passing in the name of this 51 plugins repo and this plugin names argument, and then the Voxel 51 / plugins for that. And once you have that, if you choose to do that, then you will have access to, in your operators list, the install plugins operator. So if we hit the backtick or tilde button on our keyboard to pull up our list of plugins, we type in install, we will see this install plugin operator here, which gives us a bunch of options. And we are going to go to the community tab, and this community tab has all of the plugins that are listed. If we go back over to the 51 plugins repository here, it's all the plugins that are listed in this community plugins table. And this is dynamically generated. So as plugins are added to this repo and the README here, then the list of plugins that appear in this list for you will also update. So we can see that because all three of these are community plugins, in particular, we have the PyTesseract OCR plugin here, the PDF loader here, and the semantic document search plugin way at the bottom here. You can install any of those by just clicking on it and then hitting execute. If you were to hit execute here after clicking on that plugin. If you don't have the 51 plugins management and construction plugin already installed, you can also install these by heading over to the GitHub repos for them. So if you pass in using the 51 command line interface or CLI syntax, the download command, so 51 plugins download, and then the name of the GitHub repo. So in this case, Brian Moore / PDF loader, and then you pass in whatever you need to in order to install all of the requirements. So in this case, we have to brew install popular and then to pip install PDF to image, which is what's going to allow us to generate images for the pages in our PDF documents and load them in. For the PyTesseract and Semantic Doc Search plugins, we can do the same thing with 51 plugins download and then passing in the name of the GitHub repo. And then we can install the requirements because all the requirements are Python packages for these two using the pip install -r requirements. Or you can use the 51 plugins requirements CLI syntax. So 51 plugins requirements and then pass the name of the plugin and then the install argument. So in particular, the PyTesseract OCR plugin is going to have as a requirement Pillow, which will be for image processing, and then PyTesseract, which is the Python bindings for the Tesseract OCR engine. And for semantic doc search, so searching through documents semantically, we are going to have as requirements the quadrant client. This is the Python library for the quadrant vector search engine or vector database, as well as the Hugging Face sentence transformers library. Okay, so what are we going to be doing here? Why do we need all three of these plugins? So if you've seen our week 5 plugins for optical character recognition and keyword search, then you know that we can take a set of documents. These are images for these documents in the form understanding in noisy scan documents dataset. And we can run OCR on them to get the blocks of text. And then we can use, so this right here shows all of the text. And we can click into these to see what the actual text is. You can store these in custom fields if you'd like. And once we have this text, we can use keyword search. So here we can specify the field. In this case, we want to search through the OCR blocks field in our detections. And these detections, because they're localized as bounding boxes with information associated with them, that's what we use to store and represent and work with the text data generated by our OCR engine. We can query for instance, contract, and we can get all of the documents that had the word contract in them. So here we can see the word contract is here, and the word contract appears in a lot of the other documents as well. So this is great. It's very powerful, but it may not be all that we need. It may not be all that we want. So one example where we might want a little bit more is if the OCR engine is a little bit errored in its predictions. So if the OCR engine predicts a plus sign instead of T or a 1 instead of I, then this exact search is not going to work. And even more than that, if we don't necessarily want to search for specific text, but we want to search for something that is semantically or in its meaning or concept similar to a particular text query or text prompt, then we can't do that with this keyword search. That's why we have this semantic document search plugin. So the semantic document search plugin uses a quadrant vector index and these GTE or general text embeddings, model embeddings. So we're using the Hugging Face sentence transformers library. We're using the GTE-base model. So this is the general text embeddings model, which is a way that to take text prompts. So this takes a string of text and generates a numerical vector that represents that in some way. We're going to be creating a vector index out of all of these text blocks. We're going to be using the text blocks generated by our OCR engine and creating the embeddings for each of those blocks. And then we're going to be querying the vector index with our text prompts that are embedded to see what the most similar parts, the most similar blocks of text in all of our documents are to our text query. So that sounds a little bit complicated, but the general idea is that we're going to pass a text query in, and we're going to find semantically similar text throughout our documents. This is going to be using a quadrant vector index. So you need to have a quadrant service running, and that means you need Docker running on your machine. So I have Docker desktop running for me. If you're on a Mac, you will probably need to do that. Depending on your operating system, you will need to have Docker daemons set up in some other way. But once you set up the quadrant service, then you will be able to use that. Okay. So let's get started working with a dataset. Okay, so instead of this form understanding in noisy scan documents dataset that we've used before, I actually need to use my thesis from my PhD. Now, you can use handwritten notes, you can use medical notes, you can use law documents, legal documents, you can use whatever you'd like. Anything that you might want to scan through and semantically find relevant information in, you can use. I'm going to be using my thesis, so we can go on over to our terminal, and I have my thesis located at desktop right here. So I can see the thesis right here. We're not going to look through all of it, but this was what I wrote to defend my PhD. And we're going to load that in. So the first thing we're going to do is we're going to create a new data set. And this used to be something that you could only do via the Python SDK, but now you can do that through the app as well. So this is a built-in operator that allows you to create data sets. So here we can pass the name of the data set that we want to create. So I'll call this my thesis, and then we want this to be persistent. So all changes we make will be persisted to database. And now we have this empty data set called my thesis. And once we have that, we can use the PDF loader to take this PDF, the thesis document that I had, and to create a bunch of images for the pages in that PDF and load them in order as samples or associated with samples in our dataset. So we're going to do that. We are going to use the PDF loader. We're going to specify the input path. Here it's in desktop, and it's right here. And the output directory, let's say we want to output this in a new directory called thesis pages. And let's choose, we want to do this in PNG format. We'll do 300 DPI, which is dots per inch. That's the resolution of the image that will be generated. And we're not going to delegate this execution. If you have a large document, you may need to delegate this, but this is relatively small, so it should be fairly quick. So here we're going to execute the operator, and this will parse through the PDF using PDF to image and generate a bunch of images in the specified folder and add those to our dataset. And just like that, we've loaded in all of our PDF in a bunch of images, and they're in the right order, and we can start to look through them, and we can start to work with them. So now that we have our images, the next step is going to be running our OCR engine to detect text in these images. So we can click on the Detect Text in Images button. And in this case, we are going to delegate the execution because this might be a little bit longer running. We only want to store the block predictions, not individual word predictions. And let's call the field by tesseract, and then we'll store them in the attribute OCR text. So when we click execute here, it will schedule the job. And then we can hop on over to our terminal, and using the FiftyOne delegated CLI syntax, we can actually look at this queued job. So let's type in FiftyOne delegated list. And we see the job. So this is for the operator PyTesseract OCR /run OCR engine, which is the operator that we just queued for the dataset my thesis. And it is queued at this time, and this is the current state. Now we can launch this job by running FiftyOne delegated launch. And this will run the job. It is computing metadata on every samples that need metadata computation, and it is going to run the OCR over all of our images. So now that our operation has completed, we can hop on over to the app, and we will see all of the blocks of OCR text on all of these images. And now that we have these blocks of text, we can start to make them searchable. So the next step is going to be using our semantic document search plugin to generate an index for this data set. So if we press our backtick or tilde button and we press in semantic, you'll see two options here. So if I do semantic document, it'll limit down to 2. So we have this semantic document search create index, and then we have a semantic document search text blocks semantically. So we're going to do the first one. We have to create the index before we can actually search the index. And we're going to create it from the PyTesseract. So this is going to be using the PyTesseract detections field, and it's going to be using the OCR field within that. And basically, it is looking through all of the string fields in our data set, the strings within detections, and then basically because we know that the text needs to be localized, and it is going to find whatever detection fields are viable as potential text fields to generate the index from, and it's going to find the subfield within that that is appropriate, and then we can generate the index. So we're going to delegate this operation as well, because in order to perform this operation, we're going to need to generate the embeddings for each of these text blocks. And because we have 196 samples and we have multiple text blocks per sample, oftentimes or 5 to 10, this might take a little while. So we're going to schedule this, and we're going to see our operation running right here. So check back in a moment, and we will start to search our index then. All right, and just like that, the operation for creating the index has completed. So let's go on over to the app one more time. We'll refresh our data set, and then we can start searching. So you can either access the index through the operators list. So if we type in semantic document, we'll see this search text blocks semantically, or you can click on the button. So this button in the grid actions right here allows you to shortcut to that operator. So here it's going to search within the indexed text field, which is tesseract/detections or .detections.ocr text. We can type in whatever query we want. So here I'll type in, we type in spontaneous symmetry breaking, which is a important thing in condensed matter physics, which is the field of physics which I came from. And we're going to search for that, and we're going to get all of these results. So here we see this text that says spontaneously breaks protecting symmetry. So even though the text that we searched with, spontaneous symmetry breaking, was not exactly the same as that, it still is picking up on that. There are some other examples. So in this case, we have a whole section here where it actually does say spontaneous symmetry breaking exactly. Over here, we can see dynamically induced symmetry breaking. So a lot of this text is pretty close. And if we want a text that's closer, so we wanted things that were almost identical, then we could set our threshold differently. So we used a threshold of not 0.8, but we could use a threshold of 0.9. And we can search for whatever text we'd like with this. So this is just one example. And obviously with PDF documents, oftentimes you do have access to the underlying text that was used to generate the PDF, but sometimes you don't. So sometimes you're dealing with old documents, like old manuscripts or handwritten notes, or you have old resumes and transcripts. So in those cases, you do need to run OCR, and then you go through this process of creating the index and so forth. If you have access to the text information from a separate source, then you can generate those detection text blocks first in lieu of using OCR. So to recap, what we've done here is we have combined 3 plugins together. We first used a PDF loader. So this PDF loader allowed us to take a PDF and to create a bunch of images for that in the right order and add them as samples to our dataset. We then used an OCR engine. So we did optical character recognition using the Tesseract OCR engine to extract text from these documents. Then we created a vector index that allowed us to semantically search through these text blocks to find not just which documents, but the specific blocks within these documents that contained the text of interest to us. And so this allows us to robustly semantically search through our documents. And this is, I wouldn't say a drop-in replacement for keyword search. I think that both keyword search and this are very useful, and you can use them side by side. But I hope this shows you just how incredibly powerful it can be to combine plugins together. Thanks for sticking around. I hope that this has inspired you to combine plugins in your own unique ways. So thank you so much, and until next time.